All right, hello and welcome to Chapter 4. This chapter, we are going to review something that you learned about in Algebra 1 called quadratics. And this is a word that I've always thought was really confusing in math because when you think of quad, you think of four. A quadrilateral has four sides. But a quadratic in math actually just means an x squared. And so we spent some of the previous chapters studying x to the first equations, and now we're going to study x squared equations, which are called quadratics, right? So x to the first is called linear, quadratic is an x squared. And I was curious to know, what do you know about some differences, right? So I thought maybe you could pause the video here, try and brainstorm any differences before we dive into this chapter. Just what do you know about the differences between them? Now that you have a chance to think about it, a couple big difference. One, we're going to focus a lot on graphing in this lesson. And so a linear graph is just a straight line graph. Like this one would start at 5 and have a slope of 4. And what a quadratic is going to look like is it's actually got this parabola shape, a U shape, or an upside down U shape like that. Right? So when you graph an x squared, it'll look like that. Another big difference is linears have one equation when you solve them. So like this one, if we minus 1 divided by 2, we get 5. But a quadratic equation typically will have 2. Like if you take the square root of 25, you get both plus and minus 5, so you have 2 answers. Right? So in this chapter, when I show you to solve, you'll have 2 answers to your equations. Okay, so we don't got to do this. But goal for today, we're going to learn some vocabulary as we're just starting to learn about. So like the first one would be, what is a quadratic? Right? So if you want to just make a little note about like a quadratic is an x squared equation, right? You might want to write that down. That's a word I'm going to say a million times this chapter, so make sure you know what that word quadratic means. All right, and then we're going to talk about how to graph them, and we're going to do this transformation stuff, which we've done before with A, H, and K. All right, but here we go with goal 1. Is quadratic vocabulary. So again, if you didn't already write down there, quadratic is an x squared equation. So I don't know if you want to put that somewhere there. And an x squared equation. Okay, and so their graphs, again, are called parabolas. The graph is a parabola. It's one of my favorite math words. I was hoping to name my first child parabola, but my wife vetoed that idea. But at any rate, so basically they'll have this point, like the top of the hill or the bottom of the U is called the vertex. So like in this particular example, our vertex would be 2, 4. So that's called a vertex point. Okay, so we can make one opening down, we can make one opening up. Maybe we make a different one over here. Draw our parabola shape. And again, the vertex is just an xy point. So this one is -3 for x, 1 for y. And that's the vertex. Okay, and even though my graphs are pretty terrible because I'm drawing with this weird pad thing, the two sides of a parabola are symmetrical, right? So they're equal to each other. So they have this thing that goes down the middle, which is called an axis of symmetry, and it splits it so that the two halves are equal. So that thing is called an axis of symmetry, and sometimes you'll be asked about the equation for the axis of symmetry, and an up and down line is an x equals line. So it'll always be x equals some number for the equation. In this case, it's just x equals 2. All right, so on the other one, see if you can figure out what would be the axis of symmetry equation for that. If you got x equals -3, Matt Webb owes you $6 because that's the correct answer. All right, and again, that's the axis of symmetry. Okay, and then I think the final thing we got to mention here is the vertex can either be a min or max, and so you could probably even guess just by looking at this one, right? Which one do you think it is? Right, and so this one is actually a max point because it's the highest point the graph ever gets. And over here, this is the lowest it ever gets, so it's a min or a minimum, right? So the vertex can either be a min or max depending on if it opens up, this one opens up, or if it opens down like the one on left. All right, I think that's it for the vocab. I made a note here to make sure that I cover all those things, but I think we got them all. Okay, so back in linear equation world, right, when we had a straight line graph, there was actually three different ways to write that equation, right? Three different forms. And for quadratics, for x squareds, we're going to have two different ways, right? And you don't have to know the names at all at this point. This one's going to be called standard form. I'm just throwing them at you just because you'll see them later. And then this one is called the vertex form. Okay, and so the whole point is in this lesson, we're going to graph. Our second objective after vocab is to graph in this vertex form. Later, we'll learn how to graph in standard form, but that's kind of a different procedure for doing that. All right, so we're going to graph in this vertex form. All right, and it kind of gets the name vertex form because the HK is the vertex point. So wherever the vertex is, that's the value for H and for K. So I don't know, maybe let's do an example to make it as concrete as possible. If this were my vertex 3, 2, then in my equation it would have y equals some number for a. That's going to be like a stretch or compressed number, and then we'd have x minus h squared, and we'd have plus k on the end. So this vertex h and k, these get plugged in when you do the equation, and a will normally be a number. Okay, so speaking of that, see if you can remember from before how to a, h, and k change the parent function, right? So, yeah, see if you can remember this transformation stuff. Okay, so for a is the hardest part of this. All right, a is going to do a stretch if a is more than 1. It's going to compress if a is somewhere between 0 and 1, so like a little fraction or a little decimal. Sorry, you can ignore it. And then it's going to reflect or flip upside down if a is negative. So it's going to reflect, I guess we should say reflect over x-axis if a is negative. Okay, the other parts, I ran out of space there, but h, what that's going to do is going to move it left or right. And so I would just do an example. So if it goes left, it would actually be like x plus 2. So you think x plus 2 would move it right, but it'll actually move it left. And then like x minus 3 or something, that would move it right. Sorry, I should have left space for right. Sorry. So we will put this down. Right, an example of right would be x minus 3. Okay, and so if it's inside with x there, that moves it left or right. If it's on the end, that's going to move it up or down. And again, I'll do some examples here. So it's going to go up if it is, I should probably put this as for k. It'll go up if k is positive, and it'll go down if k is negative. Right, and that's kind of normal. You expect if you add a number here, it'll make it move up. If you subtract a number, it'll make it move down. All right, let's do some examples. All right, so I would definitely get down a parent in your notes. So the parent graph just looks like that, y equals x squared. And then see if you can figure out what does a 1/4 in front do, and what does a -2, how does it change it? And if you have no idea, I'd get down decimals and try graphing it. Try graphing something, see if you can make some sense of it. Okay, hopefully you've had a chance to do this. But this one's going to compress, and they're going to say sometimes by like a factor of 1/4, and it should always say like it's a vertical. So when you say stretch or compress, it's always in the vertical sense. So basically, we're going to take vertically and compress it, smush it down, right? So that one with the 1/4 x squared is going to look like that. All right. The last one on here then, because it's a 2, it's going to stretch. So again, it's going to stretch vertically. It's going to pull it up. Okay, pull it up so it goes up faster than it used to. And then because it's negative, it's actually going to be upside down. So I'm not doing a good job of stretching it there, but it's going to be upside down and going to go sort of steeper faster than it did before. Right, so that's what the negative 2x squared would look like. And that's all the a value, how it affects the graph. Again, if you're unsure of these, I encourage you to put them in to Desmos. Okay, so here's some general questions, right? And just give them a quick shot, try it, see if you can figure out how the equation is different. 3 units up is just slapping on a plus 3 on the end. So this would be the x squared, sorry, with a plus 3 on the end. 3 units left would be on the inside. So instead of minus 3, it would be plus 3, because that's sort of opposite. The left and right is opposite. And then 4 right and down 5, we kind of have both parts. So the right would go inside here, and that would be the opposite of what we think. So we go minus 4 to make it go right 4, and then minus 5 to make it go down 5. Okay, so I want to do at least one of these here. Maybe I'll do 2 in the video, and if you got the first one, you don't need to do the second. But this is putting all this together. So to be able to like make the graph and then identify this stuff, right? I guess we haven't talked about domain and range yet. But see if you can sketch a graph of this quick and then answer some of these questions. All right, so when I graph, I always start with the vertex. And so this is going to move us right 1 and down 3. So right 1, down 3, that's where our vertex is going to be. And then the half is just going to make us compress. Okay, so it's going to get smushed a little bit from its normal shape. It's not going to go up as fast as it used to because we're multiplying by half. Okay, so that's roughly what the graph looks like. And then once we got that, we can answer a lot of questions. So the vertex is just the point. I just literally read it off the graph. It should be x1 and y negative 3. Okay, and you can sort of see that from our equation, other than like the x part is sort of reversed, right? Here's the x part of the vertex. There's the y part. Axis of symmetry is just this line that goes through there, and that's going to be an x equal line. So x equals 1 is the line there. This one should be a min because it's the lowest point in the graph. That's our lowest point. All right, and lowest point would be actually y equals minus 3. Right, that's the lowest we ever get on the y-axis is minus 3. And I point that out because that's going to help us with the domain and range. All right, so domain is like what is possible for x. Range is what is possible for y. So I'm actually going to start with range because in some ways I think it's easier to understand. So we said that the minimum for y is negative 3. All right, so that means y is going to be all the numbers that are greater than or equal to negative 3, right? Because we start at negative 3 and then go up from there. The domain is x, and so we go forever in each direction. So x can be 1, 2, 3, 4, blah, 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 and negatives this way too. So x can really be anything, and so we call that all real numbers. Okay, and you'll often see me abbreviate it with ARN, or that fancy R squiggle thing. Put that in there. All right, one more quick, just to give you a shot. If you got it, you feel like you're okay, you don't have to watch this, but otherwise pause and give it a shot. All right, here we go. This is what the graph looks like. We didn't shift left or right at all because there's no plus parts or plus or minus parts, so our vertex remained at 0, 0 where we started. All that happened is the negative part flipped it over and the 1/3 compressed it. The axis of symmetry is just that line there, x equals 0. And we have a max this time at 0. Right, that's the highest we get on the y-axis is 0. Right, we don't ever go positive. So our domain again is all real numbers because it goes out in each direction forever and ever. All right, and then for the range, because 0 is our max, we say y is less than or equal to 0. Right, we go down, we go into the negatives. We start at 0 on y, and then we go down, 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 down. All right, so that covers it. Bunch of vocab and then this graphing by using our transformations. All right, good luck with the homework.